My current video is about engineering, and in the last video I covered about the introduction to software. Engineering is a skill of designing and development, and that is the major difference between a diploma holder and engineer. For example, mechanical diploma holder, if there is some problem in the engine, like car engine, mechanical diploma holder can fix it. Whereas if you ask him to optimize or improve the engine or functioning of the engine, he can't do that because he never studied. Here comes the mechanical engineer. And same we can apply for electrical diploma holder. If there is some circuit and problem in the circuit, you ask the electrician, he can fix it easily. But if you ask him to optimize the circuit design, he can't do that. Whereas electrical engineer or electronic engineers can improve the circuit, and this is the reason we have ICs and we have VLSI technologies are there because of the electrical and electronic engineers. We have generations of hardware. We have mechanical generation, we have vacuum tube, we have transistors, we have IC, we have integrated circuits, we have VLSI, and we have fifth generation, the intelligent machines generations are there. So these generations are because of electrical and electronic engineers. That is the reason computers were very large at the beginning, but we are thankful to the electrical and electronic engineers because of their hard work and the effort. We have innovation. Because of that, we have now small and smart PCs are there, and we have smart watches are there even. Now, the engineering, if we talk about software and engineering together as an engineering. Now, most of the engineers, like mechanical engineers, electrical engineers, they object about software engineering, that in mechanical engineering, we physically produce something, we physically manufacture something. Same as the electrical and electronic engineers debate is there and their logic is there. But software is also engineered. We also design it, we also develop it like any other engineering. When we join software engineering and we try to define software engineering, we will define it as by the Pressman or by Somerville, which are godfathers of software engineering. They say it's a use of sound engineering principles to develop high quality software. Now, I'm not 100% happy with this definition. The reason is that as a beginner of this course, software engineering course, you don't know what are the sound engineering principles. But as a professional, when you finish your degree, we finish our degree, we know what is software engineering. I will study advanced courses of software engineering and database and networks and so on and so forth. But as a beginner, for me, software engineering principles are a vague or abstract term. And that is the reason I would like to have some better definition based on my experience, based on my knowledge from different sources. That software engineering is basically composed of 3 layers. I say software engineering is a framework. It has 3 layers. We have methodology layer, we have techniques, we have tools. And if we talk about Pressman definition or Somerville definition, when he is saying the application of software engineering principles to develop a high quality software, I pick one good thing from that. If you apply software engineering principles, result will be high quality software. That what they are pointing about high quality. That means if you don't apply software engineering principles, the result will be low quality software. That means software engineering principles help us to have a high quality. Now, high quality, I will like to explain. Quality is again buzzword. Everybody has his own understanding and the meaning. When we say quality, according to my understanding about quality, fitness for the purpose means software or any product must function according to customer requirements, and customer must be satisfied customer must be happy. I will explain the three layers what I was talking couple of minutes before. But before that, I would like to explain what Pressman is pointing, that applying software engineering result is high quality, and if you don't apply software engineering principles, the result will be a low quality. What are the software engineering principles according to my understanding? The methodology, techniques, and tools. So there are three layers. You apply standard methodologies, standard techniques, standard tools, result will be high quality. And I would like to break this high quality in terms of quality attributes. We have quality attributes. We have economical, reliable, efficient, functionality, and so on, so forth. For example, when we say methodology, standard methodology, when you apply these three layers, the result will be high quality. And this is, we are talking about the software engineering framework or software engineering definition. That you have standard methodologies, standard techniques, standard tools. So there are three layers, and the result is high quality software. The methodology, I have an understanding that methodology is the standard procedure. Methodology is a standard procedure for what? To analyze, design, and implement. So standard procedures to analyze, design, and development or implement. That means all the standard methodologies have three common phases. They must have analysis, they must have design, and they must have implementation. That means we must have these three phases. So methodology has phases. We call it SDLC, System Development Life Cycle. System Development Life Cycle, we call it SDLC phases. So methodology layer has SDLC, we have techniques, we have tools. Methodology layer has, again we say, standard procedures to analyze, design, and implement. First of all, I would like to explain analysis. Before going in detail, what is analysis? People have different understanding, but as per my information from the sources, again, Pressman, Somerville, Hoffer, Modern System Analysis and Design, Shelley Cashman, and my research is also from different IEEE or ACM or elsewhere, or standard libraries, digital libraries are there. Standard methodology has analysis. So analysis is comparison of existing system with the new system. So comparison of existing system with the new system. Why we are comparing it? To identify detailed requirements of the system. To identify or explore detailed requirements. That means we do analysis, we perform analysis to extract the requirements of the system, the new system that customer is demanding. Now, when we compare, for example, I have two sections. I have software engineering course, two sections. One section we have objective exam, one section we have objective exam. I compare both of them, both sections, both of the results of both sections, that which section is performing better in terms of objective or in terms of subjective. I can take subjective exam for both sections. I still can compare that subjective assessment for both sections is better, or by taking subjective exam in one section and objective exam in another section, to compare that objective exam has better results or objective exam has, so subjective or objective comparison. So compare two things to find out which one is better or what is the difference in the two. So we compare existing system, the current system running at the customer side, with the new system what customer is demanding. So that's the analysis. After the analysis phase, we must have clear-cut detailed requirements. Then we talk about design. generating alternative solutions of the problem, generating alternative solutions of the problem, and selection of the optimized or the best one. For example, I will compare or I will give example of the design. I already explained in my first slide that I try to link every topic with some implementation. We have any market where, for example, hardware market or software market is there, like in Lahore, Pakistan, we have a fee center, which is the hardware or the mobile market is there. If we talk about Jeddah, we have Khalid bin Walid Road is very popular for hardware and the software market is there. So I am locating at King Abdulaziz University, and from King Abdulaziz University we have area, it's called Suleimania. I ask my students or anyone to go to Khalid bin Walid Road to buy some hardware like keyboard or monitor or system unit or any CD, DVD drive. There are several routes. Now, as design, we must have experience of that domain. And there is a position in every software company, we call it system architect. System architect is responsible to design the architecture of the system. So design is related to the architecture also. Like the analysis, we have requirement engineering. We have analysis requirements modeling under the analysis phase is there, that I will cover the techniques later on. So methodology, design, method analysis, design. So design means when I ask him, based on his experience, he knows different routes to reach Khalid bin Walid Road, any market, for example. Now he knows if it is like office hours or like school timing, he knows this time the road directly going, which is like Palestine road, which is very busy, crowded at that time. For example, 1 o'clock or at the early morning, 8 o'clock or before 8. But based on experience, there are other routes to go there. For example, Tahliya, there are some shortcuts are there. So he will pick the possible suitable route to go there, and I will give him, for example, deadline, like customer gave us deadline like 2 hours. So based on his experience, he knows within 2 hours which route is suitable for him. Maybe it's the longest route like the internet. Doesn't matter that data is transferred by short route, it may reach to the longest route if the short route is busy, but user will not feel that data is transferred from which route. And similarly, the receiver doesn't know which route is picked to reach to his machine. So same, my student or any XYZ guy knows which route he will come within, he can come within 2 hours. So that's the based on his experience. Similarly, architect has his experience. Based on his previous experience in that domain, in that area, he will design, he will pick 3, 4 based on requirements, and then team will decide which of the architecture, which of the design is most suitable for the current project. So that's the design. And implementation mean coding, testing, maintenance, and deployment and security. So rest are the cutover activities of the project. Thank you very much. I will discuss later on in the next slide.